continuing with our rigid transformations, we are going to talk about translations. Translations, commonly referred to as slide, arguably one of the easier of the rigid transformations to work with and also to use on the coordinate plane. So a translation is a rigid transformation, isometric transformation, which means, it's a congruent item. There's no changes in the shape. Every point of the pre-image will go to the new image in the same direction and same distance. We sort of looked at this in an earlier lesson, as we say that A maps to A prime. Okay, so everything maps same distance, same direction, and it almost as if, you connect your corresponding points that you end up with what would appear to be a three-dimensional figure, possibly a prism. But we know that all of these are parallel because it went the same direction, and of course, all of these are also the same length because it traveled the same distance in the rigid transformation or the translation. So that's what we're looking at. Now, when connecting the vertices, line segments are the same length, right? They're congruent. Each point moves the same distance. And guess what? Each point moves the same direction. Okay, so again, all of that, when you do if you connect your corresponding points, if you see a three-dimensional image forming, then we know we have a translation. On the coordinate plane now, on a coordinate plane, you can represent the translation by a function, and it takes on the input of x, y, and the output. So whatever my x and y is, my translation would be x plus a and then y plus b. And all that is indicating is the a or the b value. The a is the number of units translated, and think about it, x is the x-axis. So a is the number of units translated left or right, and then b, the y-axis, the y values, would be the number of units translated up and down, positive and negative, whatever it may be. Mapping, this is how we would read the map. So as xy maps to x plus a, y plus b. So it's going to be some number that we are adding to both our x value and our y value to get a new translation. Okay. Looking here, what is the image of triangle JKL after the transformation? So it's saying that my xy's are going to, my x value is going to -5, my y value is going to +4. Mathematically, how can we do this? If I take j here, j looks like that is 0.21. So I could say j is 2,1, and it maps to 2 minus 5, 1 plus 4. And what we have is my j prime should be -3, 5. So that is how we can do it mathematically. We can also count it. Look at my x move -5. So I start here and I go -5 on my x value. 1, 2, 3, 4, 5. My y value moves a +4. 1, 2, 3, 4. And that is my location. Right there. Should be -3, 5. So that's how we can do that. And then, of course, if we were to do those transformations, we would end up, again, mathematically, L is -1, 2. So L prime is going to be -1 minus 5. And then my y value will be 2 plus 4, which maps to L prime -6, 6. Does that seem right? Absolutely not, because I did my math wrong. You see what I did right here? I switched my x and my y's. Remember, my x coordinate is actually 2. 2 minus 5 is -3, and my y value is 1 plus 4 is 5. So everybody makes mistakes. We just, it didn't seem logical, so I went ahead and checked it, and there we have it. And then if we did our k value should be right there, and then here, k prime, sorry. And then here is my new image, and if I were to try to connect that, connect my corresponding points, did I get it right? It looks like I did. Those all look to be traveling the same distance, and they all appear to be parallel. Okay, so there you go. Being able to check that and look at it, that's a lot of work right there, a lot of explanation that we've actually already covered most of this section now. Here, what rule describes this translation from pre-image to image? Being able to identify, this is my pre-image, this is my new image. So what happened? Just look at one of these and say, I went from Q, I went from negative 1, 4 to Q prime is 1, 5. So what happened? What travel? How far did I go? I could do this mathematically. I could say, hey, my x values, I have, remember this is x plus a, right? Some value. This is y plus b. I could say negative 1 plus some value is equal to 1. As I traveled from this point to this point, what happened? And then figuring out what that is, I just add 1 to both sides, right? To get my a by itself, a equals 2. So I know that my xy map to x plus 2, and then y, what happened to y? I have 4 plus b equals 5. Subtract 4 from both sides, and then b is equal to 1. So y went positive 1. Mathematically, sure, we can, sometimes the numbers are a little bit more difficult, or you can't see it on a graph, and I need to calculate those numbers, but that's what happens. But here I could also say this, that my x went 1, 2. So x plus 2, y went up 1. So it would be x plus 2, y plus 1. Again, being able to know which direction to go is very important, knowing that this is my pre-image, this is my new image. But so you can do it many different ways depending on what kind of resources you have available to you. So I have triangle QRS has these vertices, 1, 2, 3. What are the coordinates of the vertices of the image of the triangle after this translation? All right, so I'm going to fill this out real quick. Okay, so I made a quick grid here, the way I can fill it out. And I have, so my Q is going to be 8, negative 6. My R is 5, 10, 5. My S is negative 3, 3. I'm translating minus 7.6 plus 4.3. So I know all my X values are going to be minus 7.6. All my Y values are going to be plus 4.3. And then now I just, I'm filling in my X value. It's a small mathematical problem. Let's see, so if my x value here was 8, this x is 10, this x is negative 3, my y value, negative 6, 5, and 3. So it looks like the end result here is going to be 8 minus, so this is going to be 0.4, negative, I want to say negative, I think negative 1.7. Here I'm going to have 2.4. This is going to be 9.3. This is going to be negative 10.6, and it's going to be 7.3. So there's my new coordinates. Okay, again, I didn't have a graph available to me. They threw a decimal in, so it's a little bit more difficult, more challenging, but not impossible. It's just following the mathematical rules and understanding how do we translate. It didn't matter, that we were moving a decimal place. We were still moving the same amount. So those would be my new coordinates for triangle Q prime, R prime, S prime. Okay. Let's see. Randy here in example number 4 draws triangle ABC on the coordinate plane with the vertices of this. and then he translates the figure to the coordinates of the image. What rule did he use to draw the image? Okay, they've given us all of these values, and it doesn't matter which one of these. If we know how far he traveled from A to A prime, that's going to be the same as B to B prime or C to C prime. So let's just figure one of those out. So if A is 7, -4, and he mapped to A prime, which is 5, 1, what happened? I could do that mathematical thing, and I could say, hey, my x values, I got 7 plus A is equal to 5. I could say -4 plus B is equal to 1, and that would solve that mathematical transformation. Let's see here, subtract 7, and I know the A value is equal to -2. I add 4 to both sides, and I know my B changed by a value of 5. So what rule did he use? Well, my xy mapped to x minus 2, y plus 5. And that is the rule, the mapping rule. And if we would have used any of those points, we should have come up with the same value because they told me it was a translation, so that meant everything moved the same. Let's see here. Next, estimate. What is the preimage? I say estimate because we're talking about decimals on the coordinate plane. What is the preimage of the figure if the rule that created the image is this? Okay, well, let's see. I need to figure out where the heck I started, right? So if I take K, just as an example, K prime, sorry. K prime is -3, 1. So how did I end up finding that rule? Well, this is it. This got me to that location, the rule. So the x value for that would be x minus 7.5 equals -3. And that would tell me what my original kx was, which is plus 7.5 plus 7.5. So the original x value location was 4.5. So I have 4.5. And I can do the same thing with y. I have y minus 4.1 is equals 1. Add 4.1 to both sides. And then y equals 5.1. So there you go. That is I calculated where my k point is located at. So k is going to be 4.5, 4.5, and 5.1, approximately right there. That would be where k originated. So let's think about it. Does it make sense? If I started here, my x values would be subtracting. My y values would have been subtracting, so that makes sense. It's logical. So yeah, that's about where I would be. And I estimated, because it's 0.1, I'm slightly above the line. So that would be it. And of course, I could do that with all of my points. It would turn out to look something similar to I think that, once you did the drawing, something very similar to that. And you calculated that. But mathematically, this is how you would do it. We could just replicate that 3 times. Talking about another way to represent translations is vector. Okay, so just looking at vector is just a different way of writing it for me. If you look here, this is the mapping that we're used to, but in a vector transformation, we would just say, hey, we know that the value of A and B, or how much my x value and my y value moved. Well, we just would say this, vector, right? Vector A, B. So it's just saying that I'm going to take all of my x values and move them all of my points and move the x values this many, this value, and the y this value. So when they say that p negative 2, 3 is translated on vector 7, 4, they're saying that we're going to take all of our x values and add 7, y values, add 4. So p plus, or negative 2 plus 7 and 3 plus 4 gives me my new vector location, my new image. So that's just a different way of sort of defining our translations. Let's see here. So in these translations, making sure we didn't miss anything, we have quadrilateral, and they've given us our 4 vertices, and we want to find the coordinates of the vertices of the image after the translation along this vector. So they're saying that for my x values, I'm going to add 7. For my y values, I'm going to add 1. Okay, so let's see. They're telling me to graph the quadrilateral first. Okay, so now having graphed it, as I'm moving positive 7, positive 1, I know that I am going to be going this direction, right? Because my x values will be increasing and my y values will be increasing. So I should be heading in that general direction as I graph this when my new location appears. And then here it would just say, they've done it and they've said, let's take my x values, all of my x values, and I'm going to add 7 to them to come up with my new values. All of my y values, I'm going to add 1 to come up with my new y values, and that will give me the location of my new points. And if I just graph 1, the q is going to be right here, -1, -1. So that would be q prime, and s, we'll do s real quick. S prime is going to be 3, 6, which is 3, -6, which is right there. So there's my s, and if you can see, we are traveling in about that same general direction that I described. Okay, so with that, we could have graphed all the images there, but we'll move on. In this check, this quadrilateral, ABCD, has these vertices, and then what are the coordinates of the vertices of the image after the translation? Vector 5, -3. That is easy enough. We just take any one of these points, and I'm going to pick C. C is -2, 5, and it is mapping to C prime, and remember this is going to be read and mapping as x maps to x plus 5, y minus 3. So x plus 5, I have -2 plus 5, and then my y value is 5, 5 minus 3, so C prime should be 3, 2. Which one of these has C prime as 3, 2? C prime, 3, 2, right there. Not 3, 2, not 3, 2, not 3, 2. So I'm able to eliminate those 3 answers to know that that is going to be my answer. If I went back and checked all of them, they should by default fill in there, but if one is successful, then they all should have that same value. All right, so that's translations. What have we missed anything? We have definitely talked about determining the translation vector, right? How far did we travel from here to here? Just count it. We could do that. We could also do the mapping that we did before, but I would say that we went 1, 2, 3, 4, 5, 6, 7, 8. That is a -8, right? So our vector translation here was x went -8, and the y value did not change, so it just was vector -8, 0. Okay, so thinking of those kind of things. And then this other check here, right here, I mean, I could again do it mathematically, or I know that my x value changed 1, 2, 3, 4, 5. So +5 and then my y value change 1, 2, 3, positive 3. So it looks like that could be my translation there. So it could be yes, vector translation 5, 3. And let's see here, looking at this word problem real quick. Goodness gracious. Travis is on a scavenger hunt at the lake and he needs to swim to the nearest buoy, pick up a card, and then swim until he reaches the fisherman, who will give him the next clue in exchange for the card. Okay. Describe the translation from the buoy to the fisherman's boat by using a translation vector. Okay, from the buoy, describe it. As we travel, change colors here real quick. As we travel, we are going from the buoy to the fisherman's boat. So what am I doing? It looks, if you think about the coordinate plane, my x values are going to be increasing, my y values are going to be decreasing. Because my y value is going down, negative, my x value is going right, positive. So I would say that. Total, it says describe the task in your own words, then list any questions that you might have. What could you find answers to your questions? I'm just trying to think through how I would look at this and approach this, and I would say that, gosh, is there a current? I don't know, is the boat moving? There's different things like that. We're going to assume everything's stationary. And how far am I swimming? Are these meters, feet? What are the increments of these units? So we're just going to focus on just the unit. And then how can you approach the task? What have you learned? I would say that from the buoy, again, just thinking about it, if my x and my y is mapped to x, I would say I increased 1, 2, 3, 4, 5, x plus 5, and then y minus 1 because I went down 1. So that would be my mapping, and then could it be written in vector form? It would be 5, negative 1 would be vector form. And there you go. That's looking at some of those, things, some of those things that we could identify. So as we work with translations, sometimes a little equation, sometimes we can count the graphs, sometimes we have to do it mathematically with one point, all the points, but it is definitely much easier with practice.